Hello friends, welcome to my channel. Let's have a look at problem 1836. Remove duplicates from an unsorted linked list. So in this video, we are going to share a solution based on the use of dictionary and linear traversal. First, we'll read through the statement of the problem, and then we do some simple analysis, and finally we share the code. First, let's look at the statement together. So given the height of a linked list, find all the values that appear more than once in the list and delete the nodes that have any of those values. So we are required to return the linked list after the deletions. So here are three examples. So let's look at them. So in example 1, so the value 2 is repeated. So the return is 1, 3. And in example 2, so both the values 1 and 2 are repeated respectively, so the return or the result is a null list. So in example 3, so the values 2 and 3 are repeated respectively, so the return is 1, 4, right? So the additional constraints or assumptions for this problem are the following. First, the size of the problem. The number of nodes in the list is in the range given by the closed interval 1 and 10 to the power 5. Secondly, the node value is bounded below by 1 and bounded above by 10 to the power 5. So with that said, we are ready to look at the method. So what we are going to do is to use the dictionary abstract data type to do frequency counting. So we can locate those values that have frequency greater than 1. And then we do linear traversal of the linked list to filter out those nodes. So the procedure is the following. First, we do a linear traversal. The purpose is to find those nodes values that have frequency greater than 1. And secondly, we do another linear traversal to filter out the nodes with above values. So for convenience, so we could use a dummy or auxiliary node to help doing this procedure. So first, let's look at the preparation. So first, I'm going to find duplicate values by linear traversal. So this is actually a very standard operation, right? So in other words, we decompose the code or solution into two parts. I'm going to initialize a dictionary. The dictionary will store the value and its corresponding frequencies in the linked list given. So basically, it's a while loop. I'm going to introduce the current variable pointing to height at the present time, and then we do the while loop. While current, what we are going to do is that we are going to update the frequency of the current value. So in other words, current value. So we're going to increment the frequency by 1, but we need to take care of the case if the current value hasn't been put into the dictionary yet. So we'll have a default that is 0, then we plus 1. So this finished the logic, and then we are going to reset or repoint the current to the current next. So this way, after we do a linear traversal, we could locate those values that are repeated. So in other words, let's call those values in a set called auxiliary. So let's use a set comprehension. So we're going to kv in count items. So we're going to filter out those with frequency greater than 1, that is v greater than 1. So the values in the aux set are the values that are repeated. So next, what we are going to do is that, so we do the actual work. We are repointing. So we need another linear traversal to filter out those nodes with values in the aux set. So what we are going to do is that, so I'm going to introduce a dummy node, so list node. So if we just write the constructor like this, so actually the default value is 0. So it's good because the value here is greater than 1, greater than or equal to 1. But for explicitly, I'll write this here, value equals 0. So what we're going to do is that, so we set the previous to be dummy. So this is in preparation for connection, and the current to be the head. And then basically we do the linear traversal again. So while current, what we are going to do is that we want the current value is not in the aux set. So we can use if and else to do the check, or we can use a while. So for the while loop, actually take consideration like this one, two, or many twos. So in this case, I'll prefer to use a while loop, but the effect are the same. So what we're going to do is that while current and current value in aux. So here in the inner while, so the condition after the add can be checked only if current is not null. That's why we have such a condition here. So if this is the case, what we're going to do is that we set the current to be current next. Right? So if we exit this while loop, there are two possibilities. First, the current is null. So in this case, basically we're done. Otherwise, is that the current is not null, but the current value is not in the aux anymore. So in this case, we can let previous point to the current. Right? So this is always good, no matter current is null or not. So next case, if current is not null, in this case the current value is not in the aux, what we are going to do is that we set the previous to be the current, and we point the current to the current next. So this second operation can only be done if the current is not null. So actually previous equals current can be put out of this above this if block, but putting here is more logical, I feel. So with that said, we are actually finished the main logic. So what we are going to do is that we do the return. So let's write it like this. So return. So because we have introduced a dummy variable, what we need to return is nothing but dummy next. So that's the full solution for this format. So let's do a special case check, I guess. Yeah, it passes the first example. So now let's do a generic case check. Yeah, it passes the generic case. So the time complexity of this solution is O of n. N is the length of the linked list. So I guess with that said, that's about it for this video. Thank you very much.